Hey guys, welcome back. I wanted to make a brief video of explicit versus recursive formulas for any series or sequences that you see. So we see here in 21, this is similar to the K form, but these problems come from the G form of the test. So what you should have is the K form. So these should help with some of those problems on the back. So when we're looking for an arithmetic sequence, what it means for something to be arithmetic is that to go from one term to the next, you're constantly adding the same value or subtracting the same value, but really subtraction is just the addition of a negative. So we see here in 21, I'm looking at to go from 15 to 11, to go from 11 to 7, to go from 7 to 3, and to go from 3 to -1. Every time I change my term, I'm taking away 4. So we know this is arithmetic because there's a consistent change in my values. So I say, yes, it is arithmetic, and I know that I am subtracting 4 every term. But I need to use that knowledge and write an explicit and a recursive formula. So an explicit formula is what you're pretty used to. When we would write like y equals mx plus b, a formula in that form, that is essentially an explicit formula. But now we're going to change our notation a little bit. Now we're going to start using either our sub notation or our function notation. So function notation will say a function relative to the value of x. And then this over here will have an x value involved. That would be like how we write an explicit formula. A recursive formula, we often will write something like a sub n, where n is the number of the term. Whereas in the f of x, the x would be the number of the term or the input. A sub n, n would be the number of the term or the input value. So here, if we want to write an explicit formula, I know that I'm going to lose a value of 4 every time I move an x. So I know it's -4 times x. That change is -4 every single x. So the more x's I go, the more -4's I have. Now, the problem is, where do I start? Because a lot of times we think about what's our y-intercept. What is the y value that I see first? Well, I see a value of 15. But the problem is, if I plug in x equals 1 there, that's not going to work. And here's why. This 15 is not my y-intercept. That 15 is actually the value when x equals 1. That is my first term. So since that's my first term, I really have to think about what is my 0 term or my y-intercept, my term right when that line would start at the y-axis. What would that be? Well, if every time I move 1 to the right going on the x, I lose 4. So when I think about this graph, if I have my x and my y-axis, be some kind of line like this. Well, I know that when x equals 1, and you can see most of this, that y is a value of 15. But if I think about what would x be, or what would y be when x equals 0, well, I know that this change, again, to go from 15 up to my 0 term, that would be a difference of 4. And instead of going down, it would actually go up. So that starting value is actually going to be 19. So there would be an explicit formula for that function right there, f of x equals -4x plus 19. You could also say y equals -4x plus 19, or a sub n equals -4 times n plus 19. But we like to get used to this function notation now. Now when we talk about a recursive formula is going to reuse a previous value. So when we start thinking about a recursive, it's going to use the previous term. So it's going to be some manipulation of that previous value. So I could either add or subtract, or there might be something multiply it out here. That's what we have to figure out when we're looking at that recursive formula. And I don't really have any nice, easy memory trick. Just that recursive, I'm going to reuse something that previously happened. So a lot of times we use the term right before my current term. So if my current term is a sub n, I'm at the term n, so like the 4th term. If I talk about a sub n minus 1, that would be the previous term, or like the 3rd term in that situation. So I'm going to use my previous terms here. I'm going to say that a sub n is going to equal, well, what was happening between every term? I was taking 4 away. So I can say this was my previous term minus 4, and that's it. Now the problem with a recursive formula is I have to know what the previous term is, or I have to know where to start, because I could plug in a sub 5, but if I don't know what a sub 4 was, I can't solve for a sub 5. So I have to be able to figure out what that previous term was. I have to know where I'm starting so that I can start that value and identify what that next term is. So that's an example of 21. I'm going to move on and do 22 also. So it's still asking me the same question of, is it arithmetic? So I see here I add 3, here I add 4, here I add 5, and here I add 6. Because I'm not adding the same thing every time, this is not arithmetic. Now, I'm not saying that it's not a function. It could still be a function, but what I see is, since I'm not adding the same thing every time, this is not arithmetic. And we will get to those other like geometric sequences and all that. You do a lot more geometric sequences in Math 2. We'll probably touch on it just a little bit this year. So that's going to be the end of this video. I'm going to start another video and review some of evaluating the value of a function when we have a given input. But if you have any issues still on explicit or recursive functions, please let me know.